So one of the last and interesting topic, V to I and I to V converters. Why my signal need to convert, okay, V to I. So voltage signal to the current signal. So why need to convert? For example, hello. I will going to speak okay on college locations. Okay, my sound is reach okay clearly on the copper gun. So it's a 1.2. Another end of the point is a copper gun. So directly I will going to speak without any converter. Without I am going to converter means my signal is drop down. See the waveform, my signal is a drop down, so you are not getting the clear clear of that informations. So instead of the hello, you are going to receive the only whoa. So I need to send my hello information okay on the long distance. So how to send means, so through the converter I will going to convert from the voltage information, voltage signal into the current signal. Then I will you could going to you will going to transfer long distance. Instead of the copper con, you can go for the C ready. Okay, see the waveform. So current with respect to the distance, current with respect to the distance. When you will go to current with respect to the distance, so it is a straight line. But voltage with respect to distance means it's a fall down, it's a slope. So that's why V to I converter is used. So transfer the information on the long distance. So signal with respect to the distance. So draw this block diagram, and this is a small of the graph. Then next one, okay, why I want to go for the I to V converter. I to V converter, suppose I have that solar panel available. It's a current phenomena, it is a current values coming on that my sensor output. Otherwise current sensor you can use, or some other of that whatever the current sensor background of the applications. And particularly solar photovoltaic or photodiode, these are the devices produced on the current. I need to okay store the data the entire day. I need to store entire day means morning 9 to evening 9 o'clock. How to store? But storing devices available DAC system. Data acquisition is one of the storing device available, but the input of the DAC system is a voltage. So you need to use I to V converter. I to V converter used to convert and store the data. So that's why you can go for the I to V converters. Okay, then let's we go ahead on that some okay operation amplifier diagrams. So here I have, so for that one, okay, I have V to I converters. So sending the information on the long distance. So I with respect to distance is a I have show you. Another one is I to V converter of the operation amplifier I show you. So okay, first what you will going to see, V to I converters. V to I. First I show you two waveforms, so two circuit diagrams. Not waveform, two circuit diagram. What is the difference of the two circuit diagram? Okay, I'm going to apply the source. Source is applied to that which terminal? Plus terminal. If source is applied to the plus terminal means it's a non-inverting amplifier. Source is applied to that minus terminal, so it is called a inverting amplifier. Inverting amplifier means the output of the one 180-degree phase shift. Output is a 180-degree phase shift. It's a in phase. What is output of the gain of the both? Output of the gain is equal to output of the amplifier gain. It is equal to gain multiply output of the voltage of the amplifier. Output of the voltage of the amplifier. Okay, it is equal to gain multiply difference of the two inputs. Okay, so like, so you see that here is a source is there, here is a ground I have connected. Okay, here is a ground is connected, here is a source is connected. Okay, next one, my output side is load is used. What is the type of load? One resistance load. Thus this resistance load is connected to the ground here? No, instead of that one it is connected fed back into the minus side. So that's why no, it is not connected to the ground. That's why it is called as a floating type of the load. Floating type of the load, it's called a floating load. Okay, floating load, it is connected, and then followed by that one it's a one more resistance to grounded. Okay, so here is a, what about here's, okay, this side also floating type of that one load is used, and followed by the one resistance, and here is a source is used. So this is about that V to I converter, V to I converters. So let's you can look about that one I to V converters. What about I to V converters? So here you will going to see operation amplifier is there. So here I will going to minus, okay, inverting places I got connected to the source. So source is connected. So here I'll also feedback resistance is used here, feedback resistance. and the plus terminal is you will going to ground it. Otherwise, some one of the different type of that diagrams are also available. Okay, this is type of the diagram also available. I to V converter. Okay, what is that one? So directly current source I'm using. Previously I'm applying the voltage source. Suppose I will go to connect the current source directly. So current source is connected. Current source is always one resistance connected across to the source. These two is combination. What is the combination? Source and resistance. It's a combination is called current source. So voltage source means okay, source seriously connected one resistance, seriously connected. Current source means parallelly connected one resistance. Current source. Okay, current source is connected. The current source is where I am connected. I am going to connect it in inverting type place. Yes, inverting type place. So here is a one feedback resistance is used. So this is about this is type of the possible of the diagram also you will going to come. Okay, that's all. So this is about that V to I converter and I to V converters. So V to I converter means, so first as usual you will going to okay, I will going to summarize about the V to I converters. V to I converters, okay. So about the circuit diagram, I will going to say about the circuit diagram. The output load is a floating type of load. Output load is a floating type of load. Floating type of the load means the output load is not directly connected to the ground. Okay, instead of that one, the output load is connected to that connected to the input terminal and followed by one resistance to ground. Followed by one resistance to ground. That's why it is called a floating type of the load. This is a point number one. That's all. Only one point. Second one is a source. So I am going to use the voltage source. I am going to use the voltage source. The voltage source is connected either the plus terminal or minus terminal. That is their wish. That is your wish. If I will going to connect the plus terminal means it is called as a non-inverting, no phase shift. That's all. This is the point. Suppose I will going to connect the source to that here means it is a 180-degree phase shift. Okay, this is a point number 2. That's all. Over. What is the third point? What is the third point is output voltage of amplifier. This is point number 3. Output voltage of the amplifier is equal to okay, gain of the amplifier multiply difference of the V, okay, difference of the two voltage input. So V plus and V minus, difference of the two input. That's all. 3 point. I will repeat again. Point number 1. Okay, it's a floating type of the load. Floating type of the load. The load is not directly connected to the ground. So instead of that one, it is connected to that input terminal and followed by resistance to the ground. This is a point number 1. Point number 2, source. Source is a voltage source. The voltage source is connected either the plus terminal or the minus terminal. That is your base. Why my base means, suppose my output is a 180-degree phase shift means I am use the source on the minus terminal. Suppose I don't want to 180-degree phase shift. I want to same okay in phase only output means you connect the source on the plus terminal. That's all. This is point number 2. Point number 3. What is the point number 3? Output voltage of the operation amplifier. V0 dash equal to V0 dash equal to okay. What is that one? Gain G multiply VD. This is 3 point. That's all. These 3 point you can note down. Then second one, I to V converter. Previously we were discussed why do we go for that I to V converters. Then next one here we're going to see about that circuit diagram. In the circuit diagram, two type of circuit diagrams. One is you will going to use the current source. Current source, because I am going to I is the input. So I is input, you may be used as a current source. Okay, so current source is used. Current source means what? So this is a diagram about the current source. So this is a indication, arrow mark is indicated upward direction. This is a current source. Current source is always connected one resistance across the source because it is a protection purpose. It's a protection purpose. Current source, electrical student use it. We know what is current source means. You will going to draw this one. What is the voltage source? You will going to draw source connected series with the resistance. So that is about the voltage source. So here you see that one, it's a current source is connected. Yes, here is what is the point number 1. Point number 1 is current source is connected. Okay, current source is connected either the plus terminal or minus terminal. That is your base. If you want to say in phase or if you want to 180-degree phase shift, that is your based on that one. You can use the plus terminal or minus terminal. Current source is used. This is the point number 1. Point number 2, it's a feedback resistance is used. It's a closed loop of the systems. So negative feedback resistance is used. This is a point number 2. Point number 3, output of that operation amplifier is equal to output of the operation amplifier is equal to gain multiply okay difference of the input. That's all. As usual, output of the third point is similar. Okay, so either you can use for the current source as an input or you will going to use for the as an voltage source as an input. Current to voltage converter, voltage source as an input, whatever the type of that one you will going to use. So voltage source means source connected series with one resistance. I have connected, yes. So this is about the I to V converter and the V to I converters.